Good evening, everyone. Welcome, and thank you all for coming here to SFU's Morris J. Wask Center for Dialogue. I want to begin by acknowledging that we are privileged to do this work today on the unceded territory of the Musqueam, Squamish, and Tsleil-Waututh First Nations. My name is Fred Popowich, and I'm the Scientific Director of KEY, SFU's Big Data Initiative, as well as your moderator for this evening's event. And on behalf of Simon Fraser University, I have the pleasure of welcoming you to our Fall 2018 Data Visionaries Series, a series dedicated to bringing together pioneers in the field who are shaping and reshaping the world that we live in. So I'd like to encourage you to join in on the conversation today over Twitter using the hashtags SFUKey and hashtag Data Visionaries. And if you are tweeting, just make sure you have your device on vibrate or some sort of silent mode. Otherwise, we get to hear different people's ringtones. And it can actually be an interesting data collection experiment as well, hearing the different ringtones that we have and the different chirps. So for tonight, the title of tonight's event is AI and the Transportation Revolution. Who actually benefits? And really, many people are saying we are on the verge of a transportation revolution that is changing the way we move, not only in our cities, but in our countries and around the world. And as part of our Big Data Initiative, we're taking a look for these different issues that are affecting society. And transportation is basically, pick an issue related to transportation, and everybody has an opinion on it. So it's an easily understandable topic for everyone. And transportation is broad, so it includes not only roads, which have shared use, and if you have a topic on this, you'd see how much it should be shared between buses versus LRT versus bicycles and stuff like that. So we could have a whole separate debate on just even on roads. But that's not the only part of transportation, whether it be in the cities and beyond. There's the air above us. And it's not just air traffic control that we're worrying about in planes. Now it's going to be drones, or is it going to be your groceries being delivered? Or if you want new groceries, you just shoot down a drone based on the data that you get coming from it, that it is something that you want, right? We have the waterways. In Vancouver, we're right on the water, so water is a key aspect of transportation in the city, not only for freight, but we have their passenger ferries coming in and out. We have cruises, and we even have if you're in from out of town, make sure you take one of the False Creek ferries for going across the water between different parts of downtown. And of course, we have the rail, which was the original thing the ribbon that brought our whole country together. And is it the rail that takes us across the nation? Within the city, it won't be going down the Arbutus corridor, or maybe it will be. I guess we'll see on that. So when you think of it, whether it be roads, air, water, or rail, three of these four are highly controlled, and increasingly so now on the fourth as well, because now in terms of you have to be, there are devices telling us which way we're supposed to be turning, whether we're turning left or right, or whether you're going to be listening to them. And what if somebody takes control of that, you know? And well, then we have they did a Hollywood movie on that already, so we've done that already. So you can imagine with all these different modes of transportation, not only are there's going to be coordination problems, but you can see why relating to with all the new data that is being generated and used in all these different modes. This is rich in data, and whenever you have richness in data, that's a rich opportunity for artificial intelligence. Because although AI has been around for a long time, and yes, I know you can tell by the lack of hair there, I got my PhD in AI back in the 80s, so it has been around for much longer than that as well. But and was actually a PhD in the Department of Artificial Intelligence way back then. So it's when people are saying we're going to have a big breakthrough in AI, it's a new field. No, it's been around for a long time. And really a lot of the recent hype or advances in AI have really been powered a lot by this data that we have now all have available. People are interested in AI. Really, a lot of it boils down to the predictive and categorization capabilities. And really, a lot of the value is in terms of drawing together data from different sources. So if we're taking a look at AI in the context of transportation, what actually gets lost in the conversation too often is who actually benefits from all of this. And as the cities and countries and the world and the technologies we use, as we learn and adapt, we really wanted to start a bit of a critical conversation on here in terms of tonight, who actually benefits and how people and organizations can leverage these technologies to support us equally or maybe unequally. So this is why Keys is so pleased tonight to introduce our panelists that we have with us tonight. And we're covering the country in terms of this. So let me start here by first introducing to you Shelley Chapelski, who is, if you'd like to come up here, Shelley. She is one of the most recognized shipping lawyers in Canada. She is the head of shipping at Norton Rose Fulbright, Canada, and the National Vice President of the Canadian Maritime Law Association. Her practice encompasses all aspects of maritime law, including contracts, torts, creditors' remedies, marine insurance matters, drafting and advising on charter policies, contracts of carriage, moorage contracts, insurance policies, and other agreements arising in maritime and transportation law. Her practice also deals with casualties, vehicle arrests, and limitation of liability proceedings.
Vessel arrests.
Vessel arrests, okay. I misread here. Obviously, my contacts are not the wrong mode, okay. Thank you very much, Shelley, for joining us tonight. Next, I'd like to introduce to you Jason Millar. Jason, he has had the longest trip for coming into today. I knew he was coming from out of town because when he had the briefcase with him, that was the key telling point that you're coming from out of town. Jason is now an assistant professor in the School of Electrical Engineering and Computer Science at the University of Ottawa, and an affiliate researcher at the Center for Automotive Research at Stanford. He investigates the ethical engineering of robotics and artificial intelligence with a focus on empowering engineers to integrate ethical thinking into their design and workflow. Jason's work focuses on the ethical engineering of automated vehicles, AI, healthcare robotics, and social and military robotics. Jason has a degree in engineering physics and has worked for several years as an engineer before turning his attention to issues in philosophy and applied ethics. Thank you very much for joining us tonight. And I'm now very pleased to introduce my colleague from Simon Fraser University, Kevin Oldknow. Kevin is an Associate Dean in SFU's Faculty of Applied Sciences and the inaugural Director of SFU's Sustainable Energy Engineering Program and a Senior Lecturer in Mechatronics Systems Engineering. Kevin has 20 years of industrial experience, including technical, strategic, and senior management roles, primarily related to the application of clean tech to railway systems. He has published in the area of dynamics and controls, wheel, rail, and vehicle track interaction, tribology, friction control, and engineering education. And on behalf of Key, let's put together a warm welcome for these pioneering big data leaders. So I'm going to join, now you've almost finished hearing the rest of me talking, so we're going to be turning it over to our colleagues here. And the way we're going to structure things for tonight is we're going to have everybody, we're going to give everybody, and you notice there's no PowerPoint slides for tonight, and we're not being formal, we got rid of the ties, they made sure I got rid of my tie before the event here tonight. We have comfortable seats here, making sure that we're going to have an engaged information evening here tonight. And we're going to just start by everybody having 5 minutes to briefly introduce themselves with, I've already introduced their name and their background, but so you can talk a bit more about yourselves and your relationship to the topic and your position on who actually benefits. And we'll go in reverse order. So Kevin, over to you first for your 5 minutes, and I have my timer here.
Sounds good. Thanks very much, Fred. So just a little bit more about my own background and then connection to the topic. As Fred mentioned, I spent most of my industrial career in the area of railway systems, particularly looking at vehicle track interaction and wheel-rail interaction on freight and passenger systems in a variety of settings around the world. And then more recently, after joining SFU, I picked up the role in deploying our new program in sustainable energy engineering. And within that program, a couple of the areas that we're aiming to focus on are smart cities and clean transportation. And those two things really come together and inform each other and help each other. So that really brings kind of to the fore an overlap with big data, with AI, with these kinds of things. So having said that as a bit of background, the connection to the topic for myself in many ways goes to the railway-related experience. What I tend to think about most is time spent in heavy haul freight applications. That's where I spent most of my time out in the field and out in industry. So looking at kind of very, very big trains traveling long distances and carrying very, very heavy goods. And if you think about The scale of that industry, you're talking here in North America about tens of thousands of kilometers of track with tens of thousands of very heavy vehicles rolling on that track and stressing the infrastructure in a very real way. You look at your typical freight car as it goes by, and it weighs 286,000 pounds, and that's distributed just across 8 wheels with very, very small contacts, and so that creates enormous stresses. So if you think about this, that's a system that is under very heavy load, but doing an incredibly effective job in moving things around very efficiently. And what we need to do is make sure that it's reliable and that it's staying in service and delivering its capacity. So historically, that's been done by a track inspector who's got a very trained eye, loads of experience, walking the track and looking for defects and looking for things that need to be addressed and things that need to be fixed. But if we think about what's happening now, first of all, we've got increasing traffic densities, so there's less and less time to spend on the track. We've got fewer people that are interested in jumping in and spending their time doing that. We've got a changing appetite and set of demographics in the workforce. And we've also got increasing stresses. We're always pushing the envelope in terms of how heavy the trains are, how long they are, and what we're trying to do with them. So it's a whole new set of stresses all the time. So along with that has been this explosion in sensing capability, the ability to take very good images, whether they're using cameras or line cameras, the ability to measure very small forces and vibrations, the ability to sense all kinds of things has really exploded. So on the one hand, you've got a much more challenging set of conditions under which to make sure that things are operating correctly. On the other hand, you've got this ability to generate this huge wealth of data. But then how do you take that and actually use it in a meaningful way? And that's where there's still a significant gap, is being able to take this hugely rich and large data set and actually interpret it in a way that lets you do something meaningful with it. So that's my connection to the topic. That's what I tend to think about when I look at it most often. And given that I think railways always need to be a part of the solution, whether it's these big heavy haul freights or smart cities and passenger transportation, just the efficiency of those systems means they need to be a part of the solution. And so my position on the whole thing is that there's an opportunity, I think, for society to benefit by maintaining the safe and robust and operational nature of these systems by applying AI to solve this kind of challenge.
Great, thanks for the opening statement, and wow, well done. You've set a good precedent there. So, in that context, Jason, would you like to do see how you can do
my
that?
best.
Yes.
Okay. Well, first of all, thanks for having me here. I think it's going to be a fun night. I love that we have 3 modes of transportation covered tonight. I think that'll be an interesting conversation. It actually just occurred to me that I've been working in transportation for my entire career in both phases. I never would have thought of it that way, but I started my career working in aerospace, building the things that go into the transportation system. So I started as an engineer, and I'll tell you the story of how I get to where I am now. And I think it's the best way that I've found to set the context for the research that I do now. Working as an engineer, supporting manufacturing lines. So we were building electronics for aerospace. So this was everything that went in, power systems that went into airplanes for commercial use, for space. So we have hardware that's on the ISS right now. But we also built military stuff. So my average day was looking at circuit assemblies coming across my desk, supporting their manufacturing. Most of them were just kind of rectangular shaped. And then one day I got this donut shaped circuit assembly, and I asked this is my first job, I asked one of my colleagues, like, this one just does not fit in with the rest of them. What is this? And she told me, oh yeah, that's from the guided bomb unit. And I thought, oh, of course. So, we build military things, and we also build bombs controller units as part of this. So at a very early stage in my career, I was kind of faced with this ethical situation, thinking to myself, well, it's not so clean cut. We're not just making bombs, we're also making things for the space station. It stuck in my head. I moved on to another job, not because of that, just opportunities come up. Now I'm working in transportation of a different sort, transporting information around the internet, right? So I'm actually designing chips at a company in Ottawa. And one day we started getting requests. This was 2003, I want to say. We started getting requests for features that were, without getting into the details, pulling data up from deep inside the network up to these top levels, so that, you know, in ways that were just unusual for designing these types of internet, you know, transportation systems, like the information transportation. And we started having conversations as engineers at lunchtime. You know, why are they asking for these features? It doesn't make any sense. You're not supposed to pull that data up from deep in these other packets. And as it turns out, these were the early designs for what ended up supporting deep packet inspection, traffic shaping on the internet, NSA spying, all these really interesting applications that have questionable applications in some cases, led to the whole net neutrality debate, for those of you who are familiar with that. So early on, I was exposed to these kind of ethical issues that came up in technology design. I got interested in this, and to the extent that I shifted my career and went to study philosophy full-time, and I've been doing that for the last 15 years, and that's what I got my PhD in, did a master's degree, turned into being really interested in applications, ethical applications or ethical analysis of technology, most recently robotics and artificial intelligence. So that's what I've been working on lately for the past maybe 5-6 years. But one of the things I noticed as I started engaging as an ethicist, trying to engage engineers, was that, and thinking back to when I was an engineer myself, realizing that the language that I developed in philosophy and ethics, that I was using to kind of analyze ethical situations and think about ethics and actions, really didn't connect in any meaningful way to the way that engineers think about doing their work. So when I was an engineer and I was encountering these interesting issues, I literally did not have the language to structure like an analysis of what was going on. I didn't understand how to frame the problems that I was kind of experiencing. And it turned out that ethics provides a lot of that kind of structure, the kind of language that you need to really dive deep on the ethical issues, not surprisingly, to think about them, but they don't connect very clearly to engineering. So this takes me to my current work that I've been doing for the last couple of years, which is trying to closely connect engineers and ethicists and policymakers in there as well, but using those opportunities of bringing them in contact with one another to develop a language that they can use to understand each other's work. So when ethicists talk about problems with autonomous vehicles, it's clearer to engineers what that means in terms of the actual work that they do, the coding that they're doing, or the cost functions that they're designing, and vice versa, so that the engineers have these conversations with ethicists and with policymakers, so that the kind of policy and ethical conversations are framed in a way that actually has impact on engineering practice. And so I'm very interested in finding ways of improving or just changing the way that engineering practice happens and bringing those ethical conversations into the design room. Probably going long. But now I'll attack the question, who benefits? Well, who benefits, it decides on how we design the system and how we have these conversations. So I work mostly in autonomous vehicle ethics right now. And what I've noticed is that the new car companies are like Google, Apple, Uber. These are not traditional car companies, and they think about their work like consumer electronics, like software. And this is very different than the traditional car manufacturers think about their work and think about how they distribute their technology in society. And traditional policymakers, the way that they structure the mobility system, it's very different. So who benefits is going to really depend on how we structure the ethical conversations, the policy conversations, how the technology gets designed, what kind of power structures those set up in society. Right now, it could be the trajectory where software companies get all the power, they make all the decisions about mobility, if we don't come up with more kind of nuanced ways of having conversations between everybody, including the engineers, the policymakers, the ethicists, and society, to try to figure out how we want to structure the future of mobility.
Great, thank you very much. And over to you now, Shelley, for your introductory comments.
Well, as I see it here, Kevin's about how to find and use the big data. Jason's about why do we use the data, and I'm about suing the people who do use the big data. This is brilliant the way you've organized this. I practice maritime law, and I have partners who go, oh, it must be nice to practice in such a nice little narrow area. Well, it's only been 250 years old, and it's every type of law that happens on land, but happens to involve in navigable water. So it's immensely broad. And one of the developing areas is the move towards autonomous operations of vessels, ultimately to unmanned ships. Now, 90% of goods that are imported moved internationally are moved by sea. So virtually everything you're wearing, unless it was made in the States or Mexico, came here by sea. Probably most of the equipment in this room came here by sea. Vancouver, in particular, is far and away Canada's largest port. We are a huge port city. In terms of tonnage of cargo, we're the third biggest port in North America. And the fact that we're a port city gets often overlooked in the fight about tankers, that it's all about tankers and not the fact that we are, the port directly employs 45,000 people, and then there's another 45,000 people like me who make their living indirectly off the port. So any given day, there's about 50,000 commercial vessels moving around the world, and every one of them is spinning off points of data. The data, they form data lakes. And what's a data lake but other than a repository of raw data information? And the objective of AI within transportation or marine transportation is how to collect that data, organize the data, understand and apply the data to achieve two objectives. One, to make things safer, to make the transportation by sea safer. Because if it is not as safe or more safe to employ autonomous technologies, there's no social license whatsoever to proceed. And then there's the practical reality. No ship owner is going to buy in, no port, no government's going to buy in unless cost efficiencies can be achieved. If the cost of achieving the autonomy is greater than what the current cost, there's no motivation to achieve it. So ideally, the beneficiaries are the crew, the passengers, all of us, from a safer transportation of goods and people by sea, and then secondly, greater cost efficiencies, which in an ideal world make our goods from Amazon cheaper. Because I'm convinced that someday Amazon's going to have its own fleet of ships, it's going to have its own terminal, and it's just going to control everything in a vertical integration at some point. So these points of data on a ship are everything from, if this ship is coming to Prince Rupert from Tokyo with a whole bunch of containers, it's the speed at which it's going, the different sea conditions it's experiencing, its rate of fuel consumption, its rate of emissions. Sulfur oxide emissions are a huge issue in our industry right now because they're being mandatorily reduced to heavy fuel oil is on its way out as of 2020, or it's going to be scrubbed clean, these types of fuels that are used that have high sulfur oxide emissions. How the cargo is loaded, the weight of the cargo, how it's distributed. There's literally millions of data points that are available and could be used to achieve autonomous operations and as somebody said to me, even if the ship owner doesn't move to autonomy or even unmanned shipping, by harnessing all this information, he will understand so much more about his operation. He will be able to move towards predictive maintenance. He should know the lifespan of every little bit of machinery on board that ship, so he can replace it before it needs to be repaired or broken down. It's all about achieving these finely tuned, finely run operational achievements so that everything becomes predictive, reliable, and ideally efficient and cheaper. And now, as a lawyer, I sort of stirred around at this, and I'm working on a paper about unmanned shipping, and there was two things that came to mind, and that is, what are the risks and what are the means of risk mitigation? Well, we're turning ships and cars and trains from modes of transportation that people operate into machines, independent products. So instead of a driver being liable for turning left instead of right, instead of a ship, the master of a ship making an error in navigation, it's going to be a coding error. It's going to be an algorithm that somebody inputted the wrong or an ill-advised conclusion. It's going to be the designer of the software system. It's going to be the installer of the software system. When two ships come into collision in those circumstances, how do you figure out? No judge without a whole bunch of expert evidence is going to be able to figure out which ship screwed up and at what layer in that autonomous series, the series of autonomous systems where that error occurred. So we are going to have a huge change in our liability system from traditional he drove badly, she drove badly, to each of these modes of transportation is going to become a product, and it's going to have automatic liability for their errors, and then everybody within that product who created that product can fight it out amongst themselves as to which one carries the can at the end of the day. And the best way that these risks are presently mitigated now is by everybody having insurance. So I was discussing it with an insurance broker, and he said it's going to be very interesting because most companies right now, if you're selling a product, you have a general liability insurance policy. So if somebody comes into your premises and slips, you have a CGL, a comprehensive general liability policy, to respond. If you sell something and somebody gets hurt, you have a CGL. CGLs exclude software development. CGLs exclude all that intellectual property type product. Those designers buy professional liability policies. Accountants, lawyers, software designers have professional liability policies. Professional liability policies exclude liability for property damage or personal injury. So there's this huge gap right now in the insurance and risk matrix that is going to get exploited or sort of broken open as we move forward. And finally, I also wonder about where we're going to end up in competition, that it is such a huge capital cost to enter the market with this type of technology. It's going to be, as we discussed, first out the gate, perhaps, gets to set the terms. Or I have an iPhone, and everybody in my family has an iPhone because I'm paying for the music streaming in the cloud. If our kids want to break away from an iPhone, they got to pay themselves. So the investments are going to follow the money, and instead of actually inspiring innovation, I wonder if we're going to end up with a stifling of some innovation and a lessening of competition because of the huge high cost of entry. Wow. So as a lawyer, those are my thoughts.
Oh, very interesting context from everybody here in terms of setting that, and particularly in terms of this, the issues that you've raised right now. I think we'll come back to them in some of the questions that we have here. So just so you know, the structure that we have for today, we have some initial prepared questions, which I am going to pass on to the panelists to have their comments on, and then we're just going to open it up to you in the audience for follow-on questions and that towards the end of the evening here, and then we'll have a general networking opportunity afterwards. So I think with our we have some initial great rich materials for initial context here, so I'm going to start with a first question here in terms of for our focus, and thanks for setting the context in terms of this. Now, if we're looking to the rest of the world, here we are in Vancouver, and you put the great context for what an important transportation hub Vancouver is in terms of this. What example would you hold up as something that works for applying AI to transportation? And if you have trouble finding something that works in the rest of the world, or in addition to it, maybe coming up with an example of something that you think doesn't work. So we'll let your voice relax for a second. And hey, over to you, Jason.
Sure. Okay, so I'm a little bit obsessed with this topic right now. So this is, and I think it's a perfect example of what works and what doesn't work. And I'll go into the works first. It's the easiest sell. Turn-by-turn navigation. So Waze, Google Maps, Apple Maps, Tombow, the thing that you've got in your car, whatever it is. This has been tremendously successful, and it's all based on data and AI and learning algorithms. So it's so successful that, I was having a conversation with someone earlier today who was telling me, and I've experienced this, and I'm sure most of you have, I use turn-by-turn navigation to get to places that I already know how to get to, right? Because sometimes I think to myself, well, this will maybe find me a like a slightly faster way to get there, or what I think is the fastest way. Sometimes I've thought, well, maybe, or you have an argument. Have you ever had this, like the argument with a friend that goes the same route? Oh, no, I always go left here because I think it's a little bit faster. Oh, you're crazy. I go the other way. It's always faster. And then you set the thing up and you ask Google which way is faster. This is a tremendously successful application of artificial intelligence in transportation. The interesting thing is that it's set up to be the brains of all of the autonomous and connected mobility systems. So sometime in the future, the vision is that algorithm that gets you there will be the thing that is used to route all the traffic around the city, around wherever. So this is where we start seeing cases where it doesn't work, and we're seeing the early cracks in this system right now. So recently, in the last couple of years, people have been noticing that as these apps become more and more popular, suddenly traffic is getting routed through previously quiet neighborhoods, places where it hasn't typically gone. And this is usually like quiet neighborhoods, right, in the suburbs or wherever, because the system's designed with almost a single goal in mind, which is to get you there as fast as possible. And that's a very narrow set of criteria to use, but the assumption is made that that's what everybody wants. And what we're seeing in the public now is that people are pushing back on the system, saying, look, this is having these perverse effects on neighborhoods. Also, it's not the way that city planners wanted to have traffic routed through my neighborhood. So there's this problem with the way that Waze or Google Maps fits into our democratic system of decision making. That's really interesting. And so you can extrapolate from this. So people fight back, right? They put up fake construction signs. They try to open up the app and add reported traffic accidents and things to try to game the system. And the AI pushes back again. The engineers at Waze start finding interesting ways of detecting when fraudulent activity like this, like what they would consider fraudulent activity. So it's like this arms race to keep the cars getting to their destination as fast as possible, which is a questionable goal in the first place, right? I might want to flip the switch that says choose a route that avoids quiet neighborhoods. I have kids. I know other people have kids. I don't, if they're playing on the street, I want them to be able to play on the street. So extrapolate to the system where you've got the autonomous and connected vehicle system. All sorts of decisions are being made by this concentrated algorithm, like who gets access, where do the cars go, how are you distributing risks in the system? Like where is there more traffic, less traffic? Who would make decisions about what kind of cars get to go where? Maybe Mercedes strikes a deal with the city or whatever. Could this happen so that they get preferred access on certain routes? It's not clear how all these decisions are going to get made, but these distribution problems, like distributing patterns of mobility throughout the system, are going to change dramatically because we have relatively little control over it today. You hop in the car whenever you want, you go where you want, you get there when you want. But all of that changes when this is mobility as a service. Everything's dialed up on your app. Depending on how you pay for things, you get different levels of service, and so I think that's a perfect example of where it works and doesn't work.
Yeah, perfect example there. And in terms of, since we're talking about roads and transportation and who is benefiting there, because the metric was based on time, clearly it's for the driver or the people in that car to benefit, and the score based on the population of the people in that neighborhood and their kids, they are not benefiting.
Sure.
In the flip side there. Yeah.
But interestingly, I would say it also doesn't give the passenger in the car or the driver, however you want to characterize them, the opportunity to express their preferences in terms of how they feel traffic should be routed. So I'm given three options: the fastest, the second fastest, and the third fastest, or the fastest, a similar ETA if there is one. So
not even a choice saying least amount of carbon on average. That would
exactly.
Be,
right. Yeah. And I'm also given the option to avoid toll routes, right? I think that's the other one that you get.
That's why they go in Westminster, or they used to. Yeah,
right.
In terms of that.
I just
Shelley,
argue with my GPS. I just yell back and forth with her.
Right.
Because I'm frustrated. I've made it a female voice, and I'm very frustrated she hasn't learned my preferred routes. And I just argue with her.
Sometimes
Why don't
I
you
disobey just for the satisfaction of it.
I do too. I'll sometimes turn left when it tells me to go straight, just to see where it takes me. Yeah.
Maybe this is a way of fending off Alzheimer's and stuff like that. So this is a way of new exercises for another benefit for society. Well, since we're talking about roads, and before we ask other, are there any things you'd like to add to it, like from your lawyer point of view, that you'd like to add to it, like from the and even liability point of view, from this sat nav, as they would say in Britain, the sat nav kind of approach, Well,
I can see some creative lawyer deciding to do a class action suit on behalf of a neighborhood. And,
Sure.
yeah.
Kevin, any other comments on this
Just
one?
that it's the classic case of where do you draw the boundary around who is sort of the customer and who is the end user, and depending on where you draw that boundary, it results in a different set of criteria and a different optimal design. So it's fascinating to think about.
And it results in, like, from the technology point of view, like from the artificial intelligence and the scoring functions, so much is dependent on what you're using as your evaluation function, or what are the attributes that are contributing to that evaluation function. That's interesting. In terms of examples, Kevin, in terms of what you would like to, any quick ones that you'd like to add in terms of what are wins or what are things that are done well elsewhere or not done well?
Yeah, sure. So I'll bring us straight back to trains. You know that I'm going to do that. And what I'd say, first of all, is that here in North America and right here in the Lower Mainland, there are huge innovations going on all the time. The question was asking largely about other places in the world, so I thought I'd pull one or two of those. Now, if you imagine, when you put a document on a scanner and you watch that line camera go by and generate the image, if you take that kind of a camera and mount it, let's say, beside the track, it's remarkable what the quality of the image is that you can get of trains going by. So you can actually get very, very high quality images of the side of a train as it goes by using something that in effect is similar to a scanner line camera, more robust, more sophisticated. And so I remember it was almost 10 years ago, I was visiting a railroad, and it was in mainland China. And they had a system like this set up that was capturing images of every single freight car, every single train going by. And this is hundreds and thousands of cars going by. And I remember thinking, wow, that's a lot of images. Like, how are you possibly going to process all these images and make sense of it? With the objective being to look for problems, look for things that needed to be fixed and so on. And so the tour continued, and we went into a room, and it was about 50% bigger than this room, but it was filled with technicians, with people, each one of them with a monitor in front of them, each one looking at one image at a time, right? So ultimately, it was still people looking at every single image and using their own expertise. And I can remember 10 years ago thinking, okay, well, this can't be the end of the story. We need to get farther than this. So if you look where we are now, pop over to the UK. Take that same kind of camera, instead of mounting it on the side of the track, mount it on the train and let it go by, and let it actually take a picture of the rail, take a picture of the track. You can again look for defects and things that need to get fixed. And now we've reached the point where machine vision and some use of AI can look for probable defects. So rather than having someone sit there and watch 8 hours of footage of, mile after mile after mile of track, the system can say, okay, hang on, I think this might be a defect. I'm going to narrow it down to 100 things that I think you should look at. If this is a defect, let's send someone out to fix it. So that's getting better, but ultimately, you're still relying on the expertise of a human being to say, yeah, actually that does need attention. Ultimately, where you want to get to is the system being able to say, whoa, there's a problem here, let's dispatch someone, let's fix it. But this brings to the second bit of the question, which is, in what way doesn't it work, and where is this gap, which maybe will never be closed? As we push these systems farther and farther, right, as we get better at running the infrastructure and we solve problems, we uncover new ones. It's like a receding horizon. As I learn to solve one disease and the lifespan of the system extends, something else pops up. And that new thing is going to take some level of understanding that isn't built into the system that's trying to look for it. So that may be a horizon that we'll perpetually chase and never quite get to. But I thought I'd throw that in as sort of a bit of an example.
Great, thanks. Anybody want to make any comments or question from the stage here before we pass it on to you, Shelley? Over to you for your little insights.
I've got a machine learning example that Google engineers working with some NGOs have found ways of identifying illegal fishing internationally, especially in marine protected areas. These ships are going around the world, spinning off their millions of data points. And depending upon the type of ship, it usually has a consistent course. And fishing boats in particular will have distinctive courses based upon setting the nets, picking up the nets. And Google, working with some people in the industry, and looking at millions and millions of data points, have identified typical course plots for types of ships. BC ferries are going to have very consistent. And this is all this AIS, automatic identification data, that is spun off. You can go online right now and watch ships get moved around the harbor or anywhere around the world. And they have prosecuted illegal fishermen and identified them from these AIS points of data, establishing, well, first of all, finding them, because Canada participates in a number of international conventions to try to eradicate illegal fishing, and it involves plane flyovers. Well, if you know where you're sending your plane because there's already an indication of a illegal fish boat operating illegally in a certain area, you're also using the plane wisely, more effectively, reducing the carbon on the environment, all these resultant benefits, but busting illegal fishermen. Now, where the bad part of it is a lot of this technology is assumed to be benign. AIS, you're just sending out a ping from the ship once a minute. This is where I am. Well, it's facilitated pirates in the Suez Canal area in the Gulf of Aden. There's a tanker coming at us. Let's roll out the welcoming mat. AI global positioning has been used, can be taken over, and has actually sent up false targets, misdirected ships. Has caused all kinds of confusion. So a number of these aids to navigation that are so wonderful and that have led to a great reduction in collisions, such that I'm more a contract lawyer than I am a collision lawyer nowadays, have also, because don't have the built-in protections that they probably should have to prevent malicious use.
Okay, interesting thing on that, and just to add in something to make it, people are saying, okay, gee, we didn't realize we could do that all with data that's being transmitted from ships. Imagine if similar things were being done with data transmitted by cars. Could you be able to, with data, knowing what kind of traffic accidents, looking historically, could you make predictive analytics in terms of determining, okay, this driver is a minority report likely to cause an accident? There would be people saying, of course, that's why we won't put those transponders in cars. So making sure that nobody in a car is transmitting information identifying them. So that's why I'm glad nobody drives with a cell phone on, right? Yeah. Any other comments for in terms of that example, in terms of the maritime? That's an interesting example from, and so I had to chime in there in terms of the car, just for tying into different modalities, because we have that similar data being transmitted by cars in different ways. And people are now volunteering their data, just like they're volunteering their DNA in order to get reduced insurance premiums and stuff like that. So you can see what direction some things are coming. So any comments from either of the two of you there? Jason?
It always strikes me as the proverbial, put a frog in a pot of cold water, right? And we sort of start to get used to these things over time as the temperature of the water heats up. And it's interesting to watch things that we would have really taken exception to in terms of where is this data going and who might see it, are just sort of part of what's normal.
Okay. So this is all really encouraging. Yeah. So why don't we do a slight shift to another question here and see if we can take it in a similar direction. Okay, so I'm going to start this time with you, Shelley. What's the most exciting opportunity for Canada or BC in the area of transportation and AI, and what can we do well?
That one was a challenging question, actually. You gave me a heads up on that one, and that was the one I came up with the least. But there is a wonderful success story in this city. There is a company called Robert Allen Naval Architects. There's probably no competition in this room, so I can say confidently that company is probably the world's preeminent naval architects when it comes to workboats. That company designs tugboats, fireboats, other small commercial vessels that are built around the world and used in ports around the world. I was talking to one of the president's wife one time, and the newspaper had run a big story about what a success story this was, and their neighbor said, "Oh, that's what you do for a living. I've never understood it." So although the company's famous elsewhere in the world, it's not famous here. That company has designed a remote-controlled fireboat that has been with technology advisors in Europe, so that this fireboat can get in tight where human beings could never safely get. And marine fires are notoriously difficult to fight. There was those 2 fires on barges in the river in August and October, about which I'd heard that the hose can't reach from the shore. They were very difficult fires to fight because it required waiting for the fireboats to come around. So having remote-controlled fireboats and other workboats that can be used remotely without endangering crew lives, Vancouver company is playing a leading role in that.
Great. So the notion of autonomous vehicles again in terms of that. So Jason, in terms of from your point of view, what do you see as the most exciting opportunity for Canada or BC or maybe Ontario?
Yeah, this was a tough one for me too, but I won't get regional specific, but I will get me specific. So this is what academics do best, right? Talk about themselves, I guess. So but I believe this. So an interesting thing is, we're positioned in an interesting way in Canada to contribute to the ethical, legal, and policy issues on a lot of these autonomous vehicle questions. So I used to get asked all the time, what do you think is going to be the thing that prevents these technologies from being deployed? And do you think it's like technical problems? What is it? And aside from the weather issues that we have here in Canada and the fact that autonomous vehicles just can't see in snow or in rain or fog or anything like this, aside from that, I used to say, well, I don't think it's going to be the technical problems. We seem to, the engineers are confident that they're on track for solving most of these technical driving issues. The challenging thing is the policy side. How do you coordinate in an industry where they're competing with one another and in order to come out with safe vehicles that the manufacturers understand what their liabilities are, when they can program the cars to break traditional laws like crossing a double yellow line to get around a parked vehicle on the side. Like, it's different when I do that and I'm driving than when Ford decides to design their car to do that consistently. It's going to look like they're programming cars deliberately to break the law, different legal implications, different policy implications. So there's a lot of coordination that needs to happen on the policy side. And the reason I think we're uniquely positioned is not just because we have a lot of scholarship going on in this area, but because we don't have any car companies really that are based in Canada, right? So we don't have any we don't have the lobby, we don't have the companies that are kind of fighting for competition. The government's got a little bit of a relaxed, can take a little bit more of a focus on policy without worrying about having constantly, being charged with meddling in innovation or something like that. And I can tell you that other companies in the G7 at least, the US, Germany, countries like Sweden, they all have stakes in that game. So we have an opportunity to lead, I think, on those issues in really interesting ways, and yeah, it's not often thought of when you think of the technology and deploying the technology, but having the right policy to support the safe and effective, efficient deployment of those technologies that also doesn't upset society in strange ways, like I was talking about with the turn-by-turn navigation. That's a big challenge, and I think we can make some progress on that here.
Okay, I'm going to pass the mic over to you, or the virtual mic over to you, Kevin, for your input on what is the most exciting opportunity for Canada or BC in the area of transportation and AI. What do we do well?
Sure. So this was definitely the tough question in the bunch. I agree. I decided to take something that I've been pessimistic about for years and be highly optimistic about it and let myself get excited. And so, when you look particularly at the Lower Mainland, what we've got is a population that is very, very spread out geographically and has kind of fanned out as it's grown away from the coast. And how do you then project a public transit system onto that in a way that really serves the population well and is effective? If you've got the corridors, the public transit corridors laid down ahead of time, and then you let the city grow around that. That's one thing. But we've got the opposite problem here. And so what I like to dream about and imagine is you see what's going on with autonomous vehicles, but then also ride-hailing, ride-sharing, all these different areas of activities is some new way to kind of fan out away from the corridor and introduce a step change in how effective public transit can be. So take people that live at some inconvenient distance from a major transit corridor and give some new mixed mode way that actually does work well to get them there. And see what we can do about it that way. So if I'm wildly optimistic and dreaming for just a minute, that's what I like to think about.
We can put them on the Fraser River, to let them, that's a perfect way of doing it. Yeah, exactly.
Can I ask a question?
Sure.
Jason, I'm surprised with what you said though about Ontario, because I think of Ontario with this massive employment in the automobile industry, even though none of those automobile companies are our own. Isn't their impact in Ontario immense?
Yeah. So yes, but I get the sense that there's space because it's not the big, like it's not Detroit, right? So even though we do some design in Ontario, also there's been a huge negative. After 2008, a lot of that business went back to the United States. So the nature of the auto industry in Canada, in Ontario particularly, has changed significantly in the last, I'd say, decade or so. But I think just not having the Googles, the Apples, the Fords, the Daimlers, not having them in Canada opens up a space where we can have these dialogues in a way that I just don't see happening in the U.S. in the same way. There's the policy that's coming out on autonomous vehicles in the U.S. is mostly replacing existing safety policy and focusing on safety almost exclusively. In fact, the latest autonomous vehicle policy that was released by the Department of Transportation specifically removed like privacy and ethics and other things that were in the first version a year back. So you can see them backing off a little bit on regulation, which in ways that will leave a lot of these questions open. They like to look for the industry to sort them out. And although there's some stomach for that in the U.S., nobody wants to be the first to do it, right? It's like there are all sorts of reasons why. I think, for my answer for this panel, I think that's an opportunity that we have. Yeah, I'll stick with it. Yeah.
Great. Any final ones before we go to our last question of the first part here? No? Okay, my final question here, which you are all prepared for, before we go to the unprepared questions from the audience. So it's time for you to start thinking about your questions, because we'll have mics that'll be able to you'll be able to go up to ask your question. Is what are the biggest risks with respect to data privacy or security in the development and the use of AI technologies in transportation? I know we've already started to allude to some of these, but Shelley, I'm going to let you start with this one because you have the most data to draw on here, I think.
In 2013, they discovered in the port of Antwerp that criminals had broken into their system over the last 2 years through some keystroking technology that some of the employees let in, and they were importing drugs in containers. And this criminal organization could log onto the system, identify which containers were coming in when, and get access to those containers before the customs. It went on for 2 years before they figured that this was going on in their port. In the last year, Maersk, the largest ship owner in the world, 700 ships, has had 2 massive cyber breaches. The first one costed probably up to $300 million US. It was a combination ransomware sabotage attack, and they lost all their data. They've got all those containers full of containers full of goods, and they don't know what's in the containers. They don't know which containers are supposed to come off in each ship or at each port. Transportation of goods by sea, 90%, is all about data. Because one container could hold the goods for 20 different companies, and they need to know when that can is supposed to come off. They need to know how much that can weighs so that the ship stays stable. So by the time they cleaned all their computers, their servers, replaced equipment, it was $300 million to Maersk, and somebody pays that. So I saw an article saying, oh, unmanned shipping will be great. The pirates won't be able to kidnap crew. No, the pirates will be able to kidnap a tanker, aim it for a coast, and go and T-bone. So the cybersecurity issues are beyond. It's going to be difficult to justify the cost savings as against the costs of cybersecurity going forward.
I think that's a great way for starting this question. Okay, okay, Jason, you can step it up a notch now.
All right. So, autonomous vehicles. These rely on sensors, both external facing and internal facing for their functions, right? And we're already starting to see privacy taking a hit. So think of the Tesla. There have been 2 fatal Tesla accidents attributed to their autopilot feature. This is the driverless mode. It sort of does lane keeping and other things. It's not full autonomy, but it's fairly significant in terms of what it can do. Although other car companies are catching up now with respect to that type of functionality. So. The two fatalities. The first fatality involved the Tesla that just could not see a truck that was, straddling the highway, and the car just slammed into it. The driver of the vehicle was not paying attention. Apparently, there are various reports on what was going on in the vehicle. It doesn't matter. He wasn't paying attention. He was familiar with the vehicle. He was a Tesla fanboy, posted YouTube videos about how amazing the autonomous driving mode was, and so knew the system well, presumably, but didn't understand some key limitations of what the system was capable of. Anyway, Tesla's response was to kind of amp up the internal surveillance on the driver. So they changed the way that they were sensing driver alertness. And whether or not the driver had hands on steering wheel. Other companies are using internal facing cameras on top of that. So collecting a lot of data on the driver, which poses a privacy, a threat to privacy. And partly the problem here is that the reason the companies are eroding privacy internally in the vehicle is not necessarily to make the driver safer, but really it's to indemnify themselves in cases where there are lawsuits. So it has really nothing to do with a safety motive. They can say it is, but in a weird kind of way, it's almost like a double effect. Yes, they may be safer overall, maybe not though, because we know a lot about how people get distracted with these autonomous systems. But you can imagine that as these automated systems grow in their sophistication, both external-facing sensors and internal-facing sensors are going to be collecting more and more data, transmitting the data, and using it to change the legal situation for the car companies in cases where something goes wrong, a pedestrian walks out. So they can transfer blame, essentially, to other parties. And all of that comes at a cost to privacy because information about these people is being collected and used in ways that, and so more and more cars, more and more sensors, Internet of Things comes out. So it just kind of multiplies. So that's the threat to privacy that we see currently existing and just growing as things progress. Yeah.
So Kevin, your take in the last few minutes on this one.
Sure. So I thought about the question quite a bit and decided that I'd answer a different question instead.
You considered a career in politics.
But in seriousness, I thought there was something in the theme of what might be lurking in the data that is relevant. So I'm not just evading the question, but it also has sort of a legal and an ethical dimension to it. So I was keen to hear thoughts, and it has to do with this: if you can install a sensor somewhere that's suddenly generating a bunch of data that you didn't have before, and maybe you don't quite know yet how to deal with that data. It's taking time to figure it out. Now let's say you have a failure in your system somewhere else, and that failure costs an awful lot of money, costs money to some third party, maybe has a risk in terms of injury or worse. And then at some point it comes to light that there was something in that data that was gathered by that new sensor that you installed that could have told you that something was about to happen. There's a nervousness that goes along with that, and a reluctance. You know, if I install this system that is suddenly producing new data, do I have an onus to act if there's something generated there that could predict a risk, even though I don't yet know how to predict that risk? And so that tends to slow down the willingness to try things, to innovate, to install new data collection devices. And I think it's something in terms of what might be sitting in that data that causes a lot of caution, rightly or wrongly, and can slow down progress towards what might be a safer system ultimately.
And sometimes it could be the issue of that we not even knowing what's in the data until we look way back and then see the symptoms of it. Yeah,
exactly.
So it's interesting. Okay, so while I'm, let's, for turning it over to questions from the audience, we're going to have two people by each of those pillars there. So I see Seychelles walking towards that pillar there and Angelina walking towards this pillar here. So if you have questions so that everybody can hear it, start making your way to behind Seychelles there or Angelina there. And if we want people to be brave and stand up, and if people are feeling too constrained right now and if they're close to them, just raise your hand. We can do that to get the conversation started. So first, for the first person, a show of hands, anybody that wants to ask an initial question for the panel. Otherwise, I'm going to start asking them another one that they aren't aware of. Okay, we have somebody there. So go start with that one there, and then so the next people can start as you have questions lining up behind Angelina and between Seychelles there. So we should have turned it, we put a new battery in there. You know. Yeah, you'll have to yell, yeah.
Talk a little bit about what could change in AI and big data. Can you guys talk about individually each what you guys think won't change in the world?
Okay, so what won't change? Why don't we start with Shelley? What won't change?
Jobs for lawyers. But actually, one thing that I think is really neat, my firm was Bull Hauser, and 2 years ago we merged with an international firm, London-based Norton Rose Fulbright. And one of the things that I see them doing, which is I find fascinating, is that they see the role of a lawyer moving from lawsuits and contracts, because more and more of that's going to be taken over by AI, simple a lot of contracts and stuff, to advising their clients as to the risks, so that companies can make informed decisions, boards of directors can make informed decisions as to what risks they're prepared to accept and which ones they're not. Whether that be they're importing something from Africa and there's human rights issues in that country in Africa. Publicly traded companies, the public is demanding more and more accountability in terms of environmental, societal, and governance from them. And I'm enjoying working at a law firm that sees, as AI takes over the traditional roles of lawyers having to be more of a risk advisor.
Interesting. So what data is not going to change, Jason? Any insights?
Well, so one of the things I've heard companies who are disrupting talk about is how they change everything. Like if they make a technology that people like and like I use the Facebook. I pick on Facebook for this a lot. So Facebook famously, Mark Zuckerberg, for 7 or 8 years would always, whenever a privacy concern came up, he would always counter and say, "We're changing the way that people think about privacy. Your concerns over privacy are outdated. You're thinking the wrong way. We design our technology this way. We've got lots of people using it, so clearly people have changed their views on privacy." And when you do the research, it actually turns out that that's not the case. They change. So what happens is the privacy concerns are anchored in these kind of social expectations that they have with people that are that they're using the application with. So my kids will expect that I'm not looking at they don't use Facebook. They think it's for old people. But so kids 5, 6, 7 years ago would report that they were shocked when their parents were looking at their Facebook profiles. Because the social expectation, like privacy being grounded in the social relationships, hadn't changed. kids have always expected and been bothered by their parents invading their privacy, right? Parents just didn't understand what the social norms were for using Facebook among kids, right? It would be like reading your kid's diary or something like that. You just shouldn't, you shouldn't do it. It's just, that's the expectation. So I think, and this is just my way of saying that, that what won't change is that these kind of ethical or social norms will be grounded in relationships and between people, whereas technologists and engineers often think, well, if I build it this way, I can change the way that people set up social norms, and it doesn't quite work that way all the time, I think. So I think in order to develop the technology well, so that we don't have these kind of privacy issues, engineers and computer scientists should be a little bit more tuned in to how those norms get set up and function in society, so that we don't get these kind of Facebook-like issues popping up.
Okay, interesting. Okay, Kevin, a brief one on you there.
Sure. So I'll say that I often say that I'm about to talk about the future, and so the only thing I can say with certainty is that whatever I say is going to be wrong. But having said that, I think what's going to be fascinating to see is, of all the things that seem tantalizingly close right now, which ones will we realize in short order, and which ones are going to be 5 years away for the next 100 years? Because it's going to be some mix of those two things, and it's so hard to know which is which and what the difference is between the two. So that's going to be fascinating to see which of these things come to fruition and which don't. And the only other thing I'd say is to echo a previous comment. I think as a society, we don't tend to be happy with status quo. We're always pushing systems to do more and to perform better, and so we push them to fail in new ways. So what won't go away are problems to solve in understanding those failure modes and then teaching the systems how to address them.
That's a nice recap there. Thanks very much. And we thank you for launching the first question there. We have another question from the front here, and then Shelley, you can look for the next question after that. Over to you.
Yeah, thank you. First, a comment. 1999, I was the accountant at the Vancouver Food Bank, and they used geodata to track the homeless. They would ask for postal codes, and the city of Vancouver offered to input those postal codes and plot them on a map. But the manipulation of data got out in the homeless community to give phony postal codes. So 10% of the homeless ended up living in the former mayor's residence. Another 10% lived at City Hall, and I think 15% lived at North Fraser pretrial. But how much manipulation, you spoke on that point, the manipulation of putting in false accident reports. How much information is suppressed from private industry that doesn't get out to the public?
Oh, so I'll just turn this into a question, or take this as a question about data ownership, maybe, right? So all of it gets held by these corporations, except, well, now things are changing in some jurisdictions, right? Like in Europe, you have access to your data now, thanks to the GDPR. Companies like Google will allow you to liberate, I think they call it liberating your data. So you can get all of the data that you gave them, but they're talking about posts on Facebook, posts on Google, or Google Circles or whatever they used to call their social network, tweets, things like that. You can retrieve the timeline of all your posts. What you can't get access to is all the other data that they've collected about your activity through the system. So all the like metadata and path data and clicks and all that kind of stuff. So, which is the vast majority of the data that these companies have on people. You get none of that, and nobody else does, right? Unless you pay for it, and even then you're only getting a curated set usually. So the amount of data that we have access to today is minuscule compared to the amount that exists. And there are significant questions about who should own that data. So in Toronto, they're coming up with this, I can't remember what the name of it is, Google's Smart City or Smart Sidewalk Labs. I can never remember the name. There are significant questions about who gets access to the data that's created by installing sensors everywhere in a public space, right? Why should Google own that? So who benefits from that data? Getting back to our original question, if we allow a Google to come in and instrument the city, who benefits from that? Who gets the data? Who gets to see it? What do you get to learn about all the other connections that they've made and profiling that's going on and things like that? Significant questions. Right now, we do not have answers for these.
Kevin, anything to add to on there?
No, I think that that captures more
Shelley,
than I could say.
anything? No, okay, he's sufficiently disturbed. Yeah, no, Mike with the next question there. Thank you.
Hi. So my background is in real-time 3D, and I've seen a lot of use of digital copies, say, for example, for a city, to then use these to train models much faster. So we talked about data and who owns it, but I'm just thinking in terms of direction. You get a lot of data, you kind of reconstruct it for in terms of training. So it's kind of like the middle way before you turn it back to the artificial intelligence. But I see a lot of problem cases there. What about in terms of liability? Like, what is the approximation of that reprojection of data that then gets used? Because sometimes it causes a ripple effect. If your AI decides something based on its training, but you had to take a couple of steps back in terms of, like, first, where does this data come from? That's already a huge conversation. But how it gets used and deformed, depending on what your choices are later, how is that going to have an effect? Because I feel like it's even earlier on in the process, and I feel whenever that causes a ripple effect, it could be huge. So where does it kind of fit in terms of ethics and even law whatsoever?
Who would like to start on that one?
I was going to say, in law, it's going to be a developing field, and I don't know how our legal system as it's presently set up in terms of establishing liability is going to function with it. Because as you say, it's also going to be a ripple effect. So maybe somebody made a partial difference here, but then if two changes hadn't occurred, then the ultimate outcome would have been changed. It gets more and more confusing. And even if you find somebody liable, if they don't have insurance or there's no way to recover from them, who cares?
Just another dimension that adds to that is when you're talking about a digital copy or a digital twin or some model of a system that you then use to represent it, to kind of understand something, the issue of scale becomes so important, but also so nuanced. You know, if I want to create a digital twin for this building, it depends whether I'm trying to understand what's going on between the entire building and its foundation, or between, you know, this glass and the table. The two things are entirely different questions and need totally different models with totally different resolutions of data. And so the risk is you've gathered data and constructed a model to answer a question at one scale, but then it gets inadvertently used to answer a question at a different scale, and the answer really, really wrong. So whose fault is it that happened? You know, that you took something that was entirely well suited to answer one question, but then very wrongly used to answer a question at a different scale.
Jason, anything you'd like to add?
Just that from an ethical perspective, like these questions about explainability are coming up all the time now. So people are asking, when you create these models, when you create the data sets and decisions get made, you know, we're starting to develop techniques and also asking engineers and computer scientists, like, try to build something in so that you can explain why that system made the decision it did based on the data. So at least it's a starting point for trying to understand what's going on with the data and where the problem occurred. Yeah.
Where I see a change also developing is going back to the ships. There's classification societies, or there's somebody that's approving all the parts that are going into that ship. Presently, they don't have a lot of liability. I think that's going to change. So that if one person does one bit and somebody else does another bit, there's got to be somebody at the end of the day that's got to be responsible to make sure that those two bits are compatible with each other, which is more often the case. You know, anything big is made up of a whole bunch of little contributions. And there's going to be verifiers. There's going to be the development of verifiers. They exist in shipping. They will probably exist in more and more businesses, and that's going to be a very dangerous job.
Yeah, great. We have a question here.
You were talking about GPS units, turn-by-turn directions. I drive for a living 10 hours a day, 4 days a week. I shuttle people around the city of Burnaby in Vancouver. And I use the GPS, just as you said, just for the heck of it. It's built into the dash. I've owned a Garmin previously for years and used it, and it was interesting. This is built in, so it's brand new technology. I was given the keys for this with 100 kilometers on it, okay? This thing gets it wrong probably 20, 30% of the time. Gives me the weirdest places to go, weirdest directions. The customers are looking going, wow, that's different. And I tell them, well, I'd like to see where it takes me. I'm curious. Extrapolating on that, GPS, I imagine, I've been told the military has their version of it, which is much finer tuned. Extrapolating on that to your self-driving cars, I would like to think that the military-grade GPS would be used in those self-driving cars, because it sure isn't being used in consumers' vehicles right now. Not at all. Would that be correct in assuming? Meaning they're highly tuned, so instead of sensing something within, say, 3 meters or 4 meters, it'll get it down to within 50 centimeters or a meter?
So without knowing the details of the differences, I think it's changed over the years. But I know that what you're getting in cars today, the average sensor, and a lot of it depends on the amount of money that you pay for the sensor, right? But the average sensor, and if you're using 1 or 2 or 3 on the car to get different information and triangulate, I think they can get you down to 5 or 10 centimeters now in the average GPS.
Yeah, but what about
in a car.
GPS specifically, though?
GPS.
A GPS,
Yeah, like a GPS
looking at a
unit.
map and taking you there, that kind of thing.
Oh, so the turn by turn?
Yes, exactly.
Yeah, so that will rely, depending on the system, it will rely more or less on the GPS, right? So if you're talking about if you're talking about my phone, it's relying on GPS plus information about wireless, like Wi-Fi spots that it picks up around. I had an experience in Chicago where I was in the downtown core, I think they call it the Golden Mile or something like that. And with all the infrastructure there, I was 2 blocks from my hotel, and it took me 15 minutes to get there because the GPS was jumping from 1 block to 10 blocks over and then back to another block. I've never seen anything like this, yeah. So still they can't deal with tall buildings in some places and L-train tracks and things like that. So
I worry about emergency vehicles too, police, ambulance, fire department.
right, yeah. I want to say that there are some solutions for this existing. So depending on the quality of the system, you can get better or worse
Depends on the
reliability.
quality of the data.
Yeah.
And we have time for one last question at the back there, and over to you there.
So I just wanted to ask, so now with autonomous vehicles and I guess with sensors inside the cabins, especially for cars, right? And one of the leading causes of death is car accidents, right? So what's the boundary between giving up data to prevent maybe accidents or injuries? Like where is the boundary where we decide that, enough is enough, like we can't go further, or so where is that boundary? Yeah.
I think that's a great question, and it's shifting as cars get more and more automated. So there's this, right now, this automated systems are relatively primitive. So on the scale, they're like they classify them level 1, 2, 3, 4, 5. 5 being fully autonomous everywhere, 4 being this kind of mystery zone, 3s being problematic because they're highly automated and they create these attention deficit problems. And then what we're dealing with today are like level 2 with most systems that are out there. As we get into 3, they're going to push more and more to get this collection because they're going to be the manufacturer going to be claiming that you need to be more and more engaged in the driving, and it's going to be harder and harder to keep drivers engaged, right? 4, nobody believes, I don't come across people who frequently believe that the high end of 3 and 4 are even possible. Google is planning to go straight to 5. They don't even want to get into this business. So it really depends on where you are in this scale and how much attention you're demanding from the drivers or from interactions with pedestrians. Most of it depends on how good the technology is. So, car companies will make choices like, well, most of the time we can detect a pedestrian, so we'll just make sure that in those cases where we don't, we transfer liability through some sort of detection and monitoring system to people outside and maybe put a flashing light or something to signal to people, watch out, I don't know you're there, or whatever. I mean, there are all these schemes that you can think of, but But it's also not clear yet how many of those schemes will actually result in saving lives. It is also part of the thing. So what may seem like a safer system will actually not be much of a gain overall. It's not clear. Like, this is all new territory, and these systems aren't really out there en masse yet. So I think it's an open question, but asking that question is it's good to keep in mind and to push that into the debate, and to ask also your car dealer when you go to buy a car, what automation systems are in here? How do they work? Is this actually keeping me safer? What are its limitations? I wonder how these things are happening, these conversations.
Kevin, anything you'd like to add there?
No, I think I'll leave it at that.
Shelley? Okay, well put. Wade, and I guess to just sort of sum up some of the things we've been hearing here, and not to cut down the conversation, because I know we'll have time to have follow-on conversation in this room here. We were taking a look at that aspect of AI in transportation, like who benefits, and if you take a look at what we heard, whether it be talking about individuals or governments and companies and organizations, those three aspects of it, individuals, governments, companies / organizations. And those organizations and companies, view them into two categories, companies for good or companies for evil, or maybe all of them are a bit of both, in terms of terrorists. Are they a company for evil, or is your favorite tech company, is it one for good or for evil, in terms of that? Ultimately, it's the usual thing we see with any advance in technology, which we've seen throughout human history, the risks versus the benefits. The thing that we've seen is the driving force in these, and the three that we've been focusing on, whether it be roads, waterways, or rail, for what we focused on today. Air is already the safest. We already know that. That's why you don't have to solve any problems there. There's no problems with the airways, right? As long as there are no drones near the airport. Ultimately, a lot of the things that are driving it are efficiency and safety. And that's efficiency can be relating to costs, to timing, amount of time for getting goods to place or people to place, or people are just another form of goods. But ultimately, those are, if you look for the two take-homes, what's driving this all? It's efficiency and safety. And in terms of the technology, so much of it is based on what are your evaluation functions for measuring efficiency or safety in terms of that. And the risks that we've heard reiterated, which are ones that no surprise that they get raised again, are these issues relating to not only privacy, but it's the flip side of some of these things relating to some of the safety is security, and specifically cybersecurity, because there's so much of it's been very eye-opening for me, some of the range of cybersecurity risks and security risks that are associated with some of the issues that we've been talking about today, and the different aspects of not just on the roads, but on the waterways and via rail as well. So with that context, we're seeing that there's increased, in all of these things, there's increased autonomy. With the increased autonomy, that's coming through the advances in these algorithms, advances in the amount of data that we have, and we see that there's a range of societal issues that need to be taken into account. And it's good that we're all here today to start these discussions, and at Simon Fraser University, we're, as part of the Big Data Initiative, we're working with whether it be individuals, companies, or organizations, and the way that I like to describe it is, if you're one of these people that you have data and have a problem, that's why you come talk to us, and we put you in touch with the right kind of people to be able to see what you can do to help address what are the issues related to it, and how can you help get more value from your data. So I'd like to encourage you to come up and engage with Shelley, Jason, and Kevin, as well as with each other, and there's refreshments out there for you to enjoy. And I want to on behalf of Key, I'd like to thank you all tonight for joining us. And I'd like to thank our panelists right here. A round of applause for them, please. And in terms of our Data Visionaries series for this month on AI and transportation, next week, I would like to invite you all to Burnaby Mountain for a lunchtime talk where SFU, or I think it's around lunchtime. Oh, yeah, got it right, good. Where SFU professor of computing science, who also is spending time in one of these companies in Silicon Valley, which we won't name them right now, but it's there's enough of them there involved in transportation. He's going to be giving a talk a week from today. Richard Vaughn is going to be speaking on robust interaction in human-robot teams. And before we break right now, I'd like to, I think we have the jar of cards up there for handing out the door prizes. I think we have 3 prizes to give out. I did not put my card in there, so if you are changing your identity, please wait until after the cards are drawn here, and we'll have, since there's 3 prizes, we get each of our panelists the choice of choosing one of these cards. That way I'm not biased. So, Shelley, you can close your eyes and choose a card, and you can announce who the winner is.
Ansad Galen?
Renewable energy, yes. Congratulations for the prize. So come over to the side here, and we have the bag for you right there. The next winner is going to be
Robert Clark.
Hey, Robert. There's something lucky about that section there. You go over there. This is a small data problem. We're going to see now if the third person is also in this section, we know. Okay.
Robert Stone.
Great. Well, thank you very much, everyone. And we have refreshments and snacks back there. And please hang around for the conversations. Thank you very much for coming out tonight. And thanks again to our panelists.
Yeah, that was really interesting. Yeah, it was really interesting. Do you guys have your cards?
That was a really good.
Yeah, that was fun. Yeah, you guys have, yeah, thank you. You're not a card kind of guys?
No, I have cards. I just constantly forget them. Yeah.
Oh, you know, yeah.